Hey everyone, okay, let's see if this works at all. So my microphone is acting funny, and if for some reason you stop hearing me, then that means I need to reconnect my microphone. Hopefully it works now. Yes, I can hear myself, so yeah, officially welcome to another live stream. And this evening we'll be doing basic fuzzing, and so basically if you've done fuzzing, if you've written a fuzzer, like a modern fuzzer, then you'll be really bored today. If you haven't written a fuzzer though, then probably stick around, since you might, I don't know, learn something, I guess. Okay, so today's moderator is Disconnected. Disconnected, yeah, this is his nickname. So on IRC or YouTube chat, if you're present, if you want to ask any question, then message this guy, and he will pass me the question telepathically, and I will try to answer it. Now, I guess let's do the usual round of updates. It will be really fast though, since I didn't prepare too much. And then we can get to fuzzing. Okay, then. Here we go. This is Disconnected website. It's partially in Polish, partially in English. And he needs to update it. But yeah, totally check it out. Thank you Disconnected for being here and helping me with today's stream. Apart from that, as usual, if you don't know Live Overflow yet, you totally should subscribe to his channel, since he's doing these really awesome videos on CTF, security, and whatnot. And I especially would like to recommend this one. It's on pen testing. It was really awesome. And the last thing I wanted to actually shout out to Jay Bosamia. He written down some notes, security notes from both my live streams and also other stuff. So if you go to his GitHub, to the security notes repository, you will find them. For example, there are some notes on advanced format string exploitation, advanced taken into quotes for some reason, but yeah, I also took them to quotes. So yeah, which was a live stream, I don't know, 2 weeks ago or 3 weeks ago, something like that, then race condition and so on and so on. And actually I'm going to copy paste you the link on all of our chats, being IRC and YouTube chat. So totally, Jay, thank you for doing that. That's really awesome, and please continue. I'm sure a lot of people will find it really interesting. Cool, so let's chat about fuzzing. So, well, currently I guess if you think about fuzzers, you think about American Fuzzy Lop, which is a kind of rabbit. Let's look for it. American Fuzzy Lop. Yeah, it's this kind of a rabbit. Yeah, and at the same time, it's also a fuzzer written by Elkamtav. Actually, if you know Polish, you probably know that last week Elkamtav visited my Polish stream and we chatted about AFL quite a lot. Though I guess AFL is currently a rather big project, so we only touched on the basics of it. That being said, since there was never any fuzzing video in English, I decided to focus on that, and I did one before in Polish, then we had one with Elkamtav last week, so I decided, that maybe, well, I decided. A couple of people pinged me after last week and said, hey, do a fuzzing stream in English, seriously, do one. So yeah, here I am. Basically what we'll be talking about today is it's basics, so really basics. If you've done fuzzing, this might not be new to you. First of all, what is fuzzing? And second of all, how do you write a basic fuzzer? You don't usually need to write a basic fuzzer, but if you know how it's written, then you probably can use it better. It's quite important to actually fully know how a fuzzer works to be able to use it in a proper way. At least that's my feeling. And third, I might touch on how modern fuzzers work, and by modern fuzzers I mean AFL. I might also, depending on the time, and I don't know how much it will take, let's say the stream will be 1 hour and 15 minutes. So yeah, then I might touch on what's the next step after AFL basically on fuzzing, but that will be only chat basically. Cool, so I guess I should mention my experience with fuzzing. So while I sometimes use AFL, there are a couple of actually fuzzers which are you know, open source and free to use, AFL being one of them. I'm actually going to copy paste the link again to the chats because it's a really awesome project. Then there's something called HonkFuzz, created by Robert Święcki. It's on Google/HonkFuzz on GitHub. I'm also going to copy paste the link. It's a little different than AFL and was created with a little different, some different ideas in mind. I might touch on what are the strong points of HonkFuzz and AFL later on, because I will be basically using them as examples. Apart from that, well, I sometimes use them, but actually during my work at Google, we also created another fuzzer with Yuru, with Mateusz Jurczyk. If you're following like Google security blog, actually we've been following it like a couple of, maybe not years, but some time ago, then you might know this post, FFmpg Google fuzzing. Yeah. This is probably not it. This is it, yeah. Yeah, it's like from 2014, that's where we basically like published our some results in our fuzzer. We fuzzed FFmpg project and we found like enough bugs that there were 1,000 fixes. And if you actually like go to FFmpg like GitHub now, if you well, not GitHub, to Git, if you grab through the log, there is about 1,500 fixes for bugs that were discovered by our fuzzer. So that's quite a lot. The difference between our fuzzer and AFL or HonkFuzz is that to use our fuzzer, you should start with like 500 CPU cores, but having 2,000 or a little more CPU cores, it's best because the fuzzer was designed actually to run with quite a lot of cores in mind. So it's designed in a little different way than you know, HonkFuzz or AFL, where both HonkFuzz and AFL are really fast on like one machine. Then, well, our fuzzer basically used that scale approach. Cool. So what's a fuzzer? So okay, there's already a question. Okay, so the question is, did I play with around with the equation group exploits? I didn't. I did read a little about it. I didn't have time to look at it yet. I might touch on it on the next stream. What's the best method to crack XOR or XOR cipher, determining the length of a key and stuff like that? I want to make some practice for CTFs, and I do not want to depend on XOR tool only. Basically, that's a good question, I think, but it's a subject basically for another stream. It's quite an interesting question. There are methods to do it, but it's like an answer would take me 15 minutes. So let's maybe, if you think this is a good topic for the next stream, then put it in the comments under this video when it's on YouTube, and then it might be like, if people vote on it, it might be a good next topic actually. Because it's totally doable. Cool. And another question, how did you analyze 1,000 plus bugs? So one important thing to mention here is that, you know, it wasn't fixed or discovered during like 1 week. It was like a year-long process or even more. And actually, the FFmpg maintainers did all the analysis and fixing work. We basically just provided the crashes, and then, since they know the project, they did the analysis and the fixes. So kudos to them. There's, especially in the blog post which I showed, there is like a list of maintainers who did all the fixes. In the end, we decided, you know, we probably don't have really time or the resources to analyze this amount of crashes, so yeah, that's why we relied on them. And it's actually something I usually do if I discover a lot of bugs, since you know, the maintainer of a project or the developer of a project does know the project really well, and it will just go faster for them to do the fixing. Okay, so back to the original topic, which is, how does a fuzzer work, or what is a fuzzer? Basically, let's see if I can draw on this. Yes, I can draw on it. Perfect. So the idea is that you take some input data. The idea is that you have a library or a program which takes input data. So let's assume this is the program, right? I guess you can see my drawing. My drawing is done with a mouse again. I probably should really hook up a pen tablet, like a graphical pen tablet. Yeah, and it takes some input, and the input is structured in a way like for example, let's assume it's a PDF file. It might be anything. It might be like a BMP file and video file, or it might not be a file at all. It might be, I don't know, just some stream of data, right? But it does take some input, and the input is in some format, and it doesn't matter if it gives any output. What matters is that if this is interesting for you from a security perspective, there needs to be some kind of a like security boundary between these things. For example, this process is actually running on a server and you're able to upload the file from your browser, right? Now, of course, if you're doing this for testing, like stability testing and anti-crashing testing, basically, then the security boundary doesn't have to be here. But let's assume but there is, because, well, you know, this is a stream about security in the end. So what a fuzzer does is basically it takes such a file and it finds, you know, the file is basically consists of a set of bytes, right, or bits, whatever. So it has some data in the file, and it does mutations, and by mutations the easiest mutator is pick a random byte, like for example this byte, which is here somewhere, right, and change it. For example, increase it by 1, or like XOR it with something, or just change it to a random value. Let's say it puts like 42 here, because why not, right? It picks a random value, and then it saves such a file. So there was like, this file was inputted here to the mutator, and it gets another file, right? Which is called a mutated file or a mutated sample. And then you take this mutated sample and you feed it back to the application. And the application processes it, but you know, you corrupted the data basically, or you changed the data in a somewhat unpredictable way. So the application might either, you know, process the data correctly if the mutation was like benign, or it might crash because the mutation wasn't benign and it actually hit a case in the application where the application would assume something, but this changed value would actually trigger an edge case, which would trigger a crash in the application. Or the application might just detect it that, oh, this is not correct data, and the application might say, oh, like error, I'm sorry, I'm not going to process this file. This is still fine. So, but in fuzzing, what you are looking for the cases where the application usually crashes, or where you are able to detect whatever error condition you're looking for. Crashing is the most obvious way to detect an error condition, because, well, something crashed. Now, this isn't the only way, and currently, like, sometimes you compile a target. This is, you know, a target again, the application that we are fuzzing. You compile it, if you're able to, with something called address sanitizer or memory sanitizer or any other sanitizer thing, which basically allows you to it actually includes additional detection in the binary itself, and it is able to detect things which would not normally crash the application but are perceived as security problems or error conditions. An example being if you overrun a buffer, right, with 1 byte, usually the application will not crash, but that still might be a security issue. Or if you like overflow the buffer, but you write something which is benign and doesn't crash the application, and the application just continues, then again having address sanitizer gives you detection of such conditions as well. How address sanitizer works is actually a good topic for another stream, so maybe later. And the third basically case where fuzzers are useful or to detect errors is if you have another application which has also processes the data, the input data of the same kind, then you just feed the same data into both applications and see if the results are the same. And this sometimes, this usually doesn't, you know, give you security errors, but difference in interpretation of the data in both libraries. But for example, there were bugs found in high precision number, like very long integer multiplication, addition, and basically math libraries. Like you took 2 math libraries and you were able to find differences in the results. And if there's a difference in results between like 2 math libraries, that means that 1 math library is incorrect, is wrong. So yeah, I don't remember who exactly did it, but some cool bugs were found this way. Okay, so yeah, so this is basically how a fuzzer works. Now, if the application crashes, the fuzzing system usually has a debugger around it. So this process is being debugged. It doesn't have to be debugged. There are other ways to know if the application crashed. For example, a core file was generated and dumped into this directory. Or you just looked at the exit code, and the exit code told you that, oh, it actually crashed. Therefore, you are able to run it again with the same input, and therefore attach a debugger and be able to analyze the crash. Now, you attach the debugger basically to get a report, and the report is basically, just a state of application, meaning like when did it crash, what were the register values, at what point in the program, like EIP or RIP registers, what was in memory, what was the call stack. These are like the basics basically in a report. And knowing that, you are able to take both the sample, the report, triage it and analyze it, and basically see if this is a security vulnerability, or maybe it's like a DOS condition, just a crash, a simple crash, which is benign. As in, it's a stability issue still, but it's benign as a security vulnerability. It's not really, just a crash. Yeah, you cannot exploit it. Cool. So yeah. So again, the fuzzer is the mutator, the detection system around it. And also, in the end, it's the thing which basically repeats this process, meaning it takes a file, mutates it, feeds it to the application. Next file, mutate, repeat, and repeat. Basically, like, rinse, repeat. So a fuzzer is supposed to do this in an automatic fashion a lot of times per second. For example, I don't know, AFL goes to several thousand per second, if not more. And then you just keep it running for a week, and you explore the process state, the state of, the space of all the possible states of the application, in hopes to somewhat randomly, find states in the application which actually cause a crash and are problematic from a security perspective. So these are the basics. Please pardon my drawing. And I guess we can code a fuzzer, a really simple fuzzer. And after I'm done, I'll tell you what's the difference between like an old school fuzzer, which I just described, and the new fuzzers. You see there are a couple of questions, so I'll answer them quickly. Have you ever used fuzzers to solve CTF challenges? Well, not to solve them, but yes, we sometimes do use fuzzers for detecting, like finding bugs in pwn challenges. It's quite useful. You don't use it always. Sometimes it doesn't make sense, but sometimes it's just easier to go through the application and analyze it. And sometimes, yes, sometimes that totally works. Especially that, like, the offer of honk fuzz, which I did mention, is in Dragon Sector. That helps a lot because he does know how to use it the best way, and it sometimes is really useful. What are the best methods to modify input files? Is it just changing random bytes, or are there any specific algorithms for that? I'll get to mutations in in 20 minutes, let's say, hopefully. Why are you so generous? Am I? I don't know. Thank you, I guess. How do you determine what areas of a program would be best to fuzz first? That's an excellent question, so let's touch on this before I get to actual coding. So it's like this. Applications are huge, right? Especially think about like Acrobat Reader. Like, it's a PDF parser, which is huge, right? And there's a lot of code for just printing the PDF, some code for displaying the windows and whatnot, right? Now, when you're fuzzing, you usually want to focus on a single input type. Well, that's not necessarily true. You might want to fuzz like a couple of different input types at the same time. But ideally, you want to take the target and carve the piece out which is responsible for parsing and processing the input type you want to focus on. And this is important because, if you focus on it, then basically you don't have to execute like everything around it, right? And executing other stuff is slow. It's slowing down your fuzzing. You don't want to do it. So You basically have to figure out which thing is parsing or processing data. And usually when you are doing fuzzing, you do focus only on parsing data and processing the data. You ignore all the other stuff. So basically, if you have an application and you know, there is like a security boundary somewhere, then figure out what input format does it process? How do you supply this input format? Is it actually feasible for an attacker to supply some, I don't know, send an email with this malicious exploit in this given format, and then if the user would run it, would that be a problem? So this is what you focus on. So it's an application specific question. It's easier usually with libraries, because you know, when you find libraries, there are libraries which are dedicated to processing some input types. For example, the zlib library does the compression on the zlib stream, right? So this is a good target. Then you have like libpng, which basically also uses zlib for the compression, but it also parses the PNG format, so or PNG format, whatever you want to call it. Or if you find like ImageMagick, you know that ImageMagick processes a lot of different image formats. So you basically grab some input like image formats and use that as the input samples. So the input samples are usually called a corpus, by the way. So it's in the old school fuzzing, it was good to grab like as many different files of the given type as possible, because that in the end gave you the best results. There were methods to actually make this corpus better, but I guess you sometimes still use it, but the currently used genetic fuzzing kinda made this a little obsolete method, though it's still sometimes used. But I'll get to that later, I guess. I hope I kinda answered your question. And okay, let's get to coding. So I'm going to code my fuzzer in Python, because why not? I guess I usually do that. Well, that's absolutely not true. By saying usually I do that, I mean when I did my Polish stream on fuzzers, I actually did code it in Python as well. I usually code my fuzzers in C++, which I'm not saying it's a good choice, it's just what we use. Okay, so what do you start with? Well, I guess we also should have a vulnerable application, but I'm going to just find it to grab one from my Polish stream, and I'm going to show it to you. Let's see, what is it? So this is the vulnerable application. It's like really, really easy. So what's happening here is, well, as you can see, not a lot. And let me maybe zoom it and quickly explain it. It opens a file. Usually when you fuzz an application, it opens a file. Sometimes it takes input through a socket like TCP socket, and sometimes it's from like standard input, but usually it's a file. So it opens a file, then it reads some header. The header are basically 32-bit ints, which are the width and height of some, let's assume, image. And then it allocates, and well, the obvious bug is here, right? It's like an integer overflow if this is a 32-bit binary, let's assume it is. Then there is no checking if the malloc returns null, because, you know, the memory allocation might fail, but it's not here, so that's a second bug. And then it tries to read here into the data, and it does this by, well, line by line, or like scan line by scan line, or row by row, however you want to interpret it. In the end, after doing this, it doesn't do anything else. So if this would actually overflow, like this equation here, this like multiplication here would overflow, then this would crash the program at some point, and this is actually a security bug. Since this is read line by line, you might this might be like, you might go to a condition where you overwrite stuff on heap. But a fuzzer does not exploit the bug, a fuzzer finds a bug. And fuzzers are useful usually for so-called low-hanging fruits, so easy bugs, which are easy to spot, easy to miss, I guess also. But it won't work for the complicated logic bugs. Usually, it just like grabs the low-hanging fruit, so the bugs which are the easiest to find. But that's okay. Okay, so this is our application. I'm going to compile it. I'm going to do it for Windows today or for Linux. Let's do for Windows because why not? Do I have do I have like 32-bit GDB installed? I do. I need to switch to it. Let's maybe use this one instead. Okay. Yeah, that should be any bad. Target, that's 64-bit, or is it? No, it's ICE. That's okay, that's 32-bit target. So this is okay. GDB is my GDB. I don't know if it's 32-bit or 64-bit. That doesn't matter. We might use GDB later as the debugger of choice for analyzing the crash. So yeah, I guess I'm going to use sub process for basically calling the target. Apart from that, I'm going to use, I don't know, that's probably all there is. I do need some input file, so I'm going to create an input file. Yeah, let me create an input file which has some, or I actually, no, I don't have, I wanted to say, oh, I have actually some input files from my Polish streams, but that's not true. So I'm going to create a file which is, basically it conforms this format, right? So let's do it like this: import struct and the struct pack. First there's an integer, 2 integers, and the integers should contain the width and height. So let's say it's 10 for 10, and then it's some bytes, so let's just do this many times for letter A. Okay, and now I'm just going to write it to a file, so open input sample, let's just call it like this because why not, right, and then quote join D. Okay, so the input file should be written now. Yes, it's actually here, and yeah, this is like width, this is height, and this is the actual data. Looks pretty much correct. So, yeah. Okay. Why Windows? Why not? I mean, it doesn't matter in the end. What I'm going to write is going to probably work on both Linux and Windows and OS X. Okay, let me continue. So I probably need to compile this as well. I'm going to also do a double check that everything is compiled. No, I think I compiled it without optimization. So what I'm worried about is that this is somewhat dead code, and I guess, well, not really true. Every it has some side effects. Maybe that code elimination wouldn't remove it in the, during the compilation phase. Let's assume it's actually there. I guess I can open it in IDA and double check. So but I also should probably compile it with ggdb to have symbols. Perfect. Should be 32-bit. Okay. Yeah. Edit compile. I'm going to just decompile it. Yeah, 2 reads, then malloc, then a loop. Looks fine after compilation, so nothing was removed by the compiler, which is perfect. Obviously, that's not a problem you're going to have with your fuzzing real-world applications, right? Cool. So, while true, you're going to do what? First of all, you're going to mutate. So maybe like this. Input samples, and this is going to just be some data. I'm going to load it into memory. I'm going to assume that the input corpus is rather small, where in my case it's going to be just one file, so it is going to be small, right? But I'm going to assume it's rather small. You can keep it in memory. That's usually the case, especially if you have a lot of RAM nowadays, right? So like keeping, I don't know, 1 GB of files in RAM is like nothing, and it's way faster than reading them with disk. So yeah, and this is, I guess I'm going to do like some def load file function that just loads the file. I guess I shouldn't do this. With binary. I'm sorry, this is Python 2, by the way. Not. It's like a thought injection. And yeah. Okay. This loads the file, load file. So input samples will actually consist only of my input sample, my only input sample, right? Which is called input.sample. Okay. And now, while true, because a fuzzer just keeps running, it never ends, you know. I'm going to grab the input sample, I'm going to mutate it. So mutated sample is equal mutate. Mutate I'm going to define in a second. I'm going to also talk about mutation methods. Input sample. Perfect. I'm assuming mutate will actually make a copy of this, so I don't have to worry about it being... because you want to keep the original sample not mutated, right? You want to still keep it in a form which is, well, clean out of any changes. So I will assume that the mutated function will actually just make a copy of it, which should be fine for Python, I guess. I'm going to just do one change. I'm going to change this into a byte array. So that's one thing, and now you need to obviously write it like write sample, mutated sample, and probably some name. I'm going to assume that the destination is the first argument. So test sample. Sorry, was the I have a typo here. Okay. Or maybe like write file or save file is a better name to keep it similar to this. Fname data with open write binary and just like fwrite. So it's going to be a byte array, right? Therefore I need to cast it to a string first. Otherwise it would say that no, sorry, don't. Okay, and now I've written it, and now I need to basically like run the application. So I'm going to do print run or execute or whatnot. And the name of the application, which is a.exe. This obviously in a fuzzer you don't hardcode stuff like that. You keep it in a configuration file or you pass it through the arguments, but you know, the stream is only like 1 hour long, so I cannot code everything correctly. I'm just basically, the idea is to show you the idea. And this is where we're going to stop at this point. So I'm just going to break. And after I implement everything, we're going to check if it works. So this is not correct because I need to do something with this import random. And random actually has something called choice, and it selects a random list element, so it like will pick one of the input samples. Now I can actually do... What do I need to do now? I need to implement mutate. Mutate, and that's going to be data. And let's assume that I'm going to actually have a couple of mutators. Mutate bits data pass mutate bytes data and mutate magic data. Okay, and here I'm just going to basically like do return random choice. This selects, yeah. Okay, and here I'm going to pass the mutator. So the mutator is going to be picked as at random the same way as, well, basically the same way as the bytes are going to be picked at random. Now, usually there are like a couple of mutators you use this, a couple of basic mutators, right? The first one is just pick a random bit and flip it. And actually, like, don't do it once per sample, do it 100 times per sample, or actually check how long is the data and flip like 1% of bits. Or the 1% here is actually a parameter you might want to tweak per target. And so that's one of the basic mutators. The other basic mutators is what I already described, like pick a random byte and change it, like increment it, decrement it, or randomly change it as into random value, or XOR it with a random value. And this is, again, usually you don't do it with just one byte. You say that I want to flip 1% of the bytes in a file. Obviously, if a file is small, then that's going to be probably just 1 byte, but that doesn't really matter. What matters is that if you have, data which is 1 megabyte long, you probably, like, changing 1 bit isn't going to be too efficient. You probably want to change quite a lot of bits all around. Then mutate magic is an interesting thing. Mutate magic is actually, well, it's like this. There is, like, numerology like thing in security, and this means there are some magical numbers, some special numbers, which usually are present when some overflow happens, and for a very good reason. And I'm going to like write down such numbers, a couple of them. This is going to be quite obvious actually, though I'm calling these magic numbers. There is no magic here. First of all, on the left, like the first element of a tuple is going to be the size of a number, and then I'm going to do the magic number. And the first one is FF. FF being, 255. And this is a common overflow, because if you do FF plus 1 in a 1 byte register, you get 0. So if you have like malloc, and then like strlen some size plus 1, no, well, that's actually incorrect, like some text length, and plus 1 to add. This plus 1 is, because you need a null terminator at the end in C language, right? So that's why you have plus 1, but you, for some reason unknown to anyone, you actually cast it to a char, or like char as in unsigned char, right? Like uint8. And yeah, this is one of the usual overflows, so this is why you would want FF to have there. Another one is just 0, because you might subtract 1 and get this. Obviously, this will also trigger like overflows if you have something like plus 3 here or whatnot, because well, FF plus 3 is also an overflow. It will give you, well, O2, which is also interesting for some reasons. So 0 is a good magic number. Then you have like 2 byte magic numbers, which is usually like the same thing, the same drill, being zeros, then 4 byte. I'm not going to go into 8 byte, but I guess you get the picture. And now, apart from that, what you also usually do is like sorry, this is obviously 4 byte. Another set of magic numbers is just let's go for 4 byte. It's this, and which is it's interesting because of 2 reasons. First of all, is like int min, meaning the minimum integer which could be written in well, the minimum value which could be written into a 32-bit integer. And there are a couple of things which could go wrong here. As you know, for example, like int min divided by -1 actually crashes programs on x86, on 32-bit x86. Then if you have like, if this is multiplied by 2, it actually gives you 1 and then 8 zeros, but since this is already 32 bits, then this doesn't fit here, so you just get 0. And I guess -1 here would overflow it to the maximum integer, which is obviously like around 2 billion. So obviously, like for half of these reasons, if something is multiplied by 4, then this value would also be interesting, because this value multiplied by 4 just gives 0 if it's done on a 32-bit numbers. And then I'm going to use also the maximum integer, which I mentioned already. I guess here you could also do 7f. So this isn't the full the full set, but it gives you the idea what these magic numbers are. Apart from that, what you sometimes like to do is sometimes you want to be a little more intelligent. For example, if you have text data, like think about XML format, like XML is obviously a text format, right? Or PDF, where PDF is a mixed format. Some data is in text and some data is obviously in binary format. But when you have like text numbers, like for example 1, 2, 3, 4, right? Like doing bit flips here makes less sense than actually like changing this number, interpreting it as a number, and changing it, for example, to 655385, for example, which is equal to obviously FFFF. But to know this, you would have to create a mutator which tries to find digits or numbers and change them as numbers, as textual representation of numbers. Apart from that, what other mutators you usually use? Sometimes you just do like random stuff. For example, you grab a piece of data which is somewhere in the middle of the file and move it. Or like you remove a piece of the file and like just, you know, take the end and the beginning and just move them together. Or you append part of a file to the end of a file. This is for some formats it doesn't make sense, for some formats it does. For example, for chunk-based formats it might make sense. So this is also another option for mutators. What other things? Let me think. I think these are most of them. There are also something which I called personally additive mutators or appending mutators, which append data. But you usually use them with genetic fuzzers, which I'm going to talk about at the end of the stream. I guess also, like, you know, truncating the file, making it smaller also is a kind of a mutator, sometimes is useful. There's a question, what can you say about sock stress? Or did you know if this is patched? I actually have no idea what's that, sorry, so I cannot answer the question. I would need to look it up. Okay, so yeah, let me finish these mutators and then we can basically go back to implementing the rest. So how many bits do we want to change? Let's say we want to change 0.1%, because why not, of bits. So this is the count, and I guess I need to make an integer out of it because currently it's a float. And well, mutate bytes will be a similar story, but without this. Also 1%. Again, this 1% is just a parameter which should be adjusted based on your target. And fuzzing is actually really important to put some love basically into these parameters that you choose for mutators. Okay, and then for, I don't know, I in range count, I need to pick a random bit. So bit is going to be bit number random and 0 to number of bits basically -1, because round end is actually inclusive from both sides. And now I need to figure out which byte is it in, you know, basic math related to bits. And now I need to actually change the data. I did mention that I need to make a copy of the data, right? How do you make a copy in Python? I think just doing something like this should be enough to make a copy. I'm going to actually check it. So I'll assume I have a byte array of ABCD, and this object has this ID. It's actually placed on this address in memory. And now I'm going to make a copy of it, and I want to see if it's the ID is different. Yeah, the ID is different. It's really close in memory, but you can see that it's actually like in a different place. So that's fine. I made a copy. Therefore, this is exactly what I needed here. I should not forget. Oh, you know what? Actually, I have a better idea. I shouldn't make this here. I should make it at the mutate function itself. Yeah, let's do it like this. So now I can flip the bit. Would you say fuzzing is something that should be done on all software, including web apps? So I'm not a huge fan of fuzzing web apps because I think there are better techniques for web apps than doing fuzzing, as in, for example, like exhaustive tests where fuzzing isn't exhaustive fuzzing. And fuzzing, you basically, you know, you have this huge space of possibilities of possible states in software, and fuzzing basically like picks random states and tests them. It's like Monte Carlo basically of security, right? And websites are usually, the input in websites is usually their patterns, like magic patterns, for example, for SQL injection and whatnot, that you can test in different input fields or parameters or whatnot, right? Therefore, this kind of approach is a little better. Sometimes people call it fuzzing. I'm not a fan of actually calling it fuzzing. So, that being said, if there are websites which actually do process complex data like file formats, which is a little different than, you know, just the user input on the website, then yeah, fuzzing could be a way to go. Otherwise, just do an exhaustive pattern-based test, and that should be actually better. That's my take on it. That being said, I am not a web application testing expert, so I might be incorrect, and if somebody thinks I'm incorrect, just let me know. Okay, so data add this byte, index byte. I'm going to flip the bit there, which is done like this. Yeah, again, basic math. And I'm going to return data, like actually the data object, perfect. Basically the same exact story for this. Do I need this I here? No, I don't need this. Count, this is, okay, this is somewhat important. What do I need to do here? What am I going to do here? Should I just put a random value here? Yeah, let me put a random value here. Random from 0 to 255. Again, it's inclusive. And then I should return data. And then the magic numbers. So how many magic numbers do I put? Let's say, yeah, I can use basically the same formula. Obviously, if a magic number is, you know, 4 byte long, then it's probably going to be some more bytes are going to be changed than if always the this number is picked, but that doesn't matter too much. I don't care. Okay, then I put I select a place. So no, first let's assume I'm going to select a random number, so n is going to be equal to random choice numbers. Size, yeah, still like this. And then I do, what do I do now? I actually have to select a spot where this is going to be put in. So x is equal to random from 0 to len of data minus, and this isn't actually going to be -1, it's going to be in size, because, you know, I should not, the boundary, this is going to, I wonder if this is going to fail hard for do a crash for files which are smaller than 3 bytes. Let me check. Import random, int, sorry, and let's do 0 and -3. Random is not defined, random. Okay, it doesn't like it seems. Yeah, I can expect that. So let's do it like this. If that is smaller than 0, then just continue. Just don't apply it. That doesn't matter. It's just like, even if like no changes are going to be applied in this loop, then the next iteration of fuzzing will apply some changes because it's, and different mutation is going to be used. So that's fine. Index is supposed to be equal to z. Yes, this is perfect, and now I can actually apply it, and to apply it, what do I need to do? So this is a little problematic, because I need to encode this number. I absolutely don't remember what is the struct for byte. Yeah, I'm just going to look it up. Okay, and this is exactly what I'm looking for. Byte or unsigned char is just capital B. So capital B and then this, and this is correct. But I could use, you know, char here or char function, which should be fine as well. I might have used a regular expression here, but if you have a problem and you use regular expression to solve your problem, you will going to have two problems. That's both saying, which is usually true. Okay, this is again byte. This is 2 bytes, so I think that's like no, that's H. I was thinking about something else. H, and this is everything here is capital I. This is I'm actually not selecting the NDNS here. I'm going with a platform default NDNS. I might make sense, might not make sense. Sometimes you usually want both NDNS, right? Because you want sometimes formats use big endian instead of little endian, and therefore this value would be incorrectly represented in the incorrect endian. Okay, and now I can do data between idx plus size or n size byte array to n. Yeah. Okay. It seems there are some. There are a couple of comments. Eodin says that this might default to, and this as well might default to 0 in case of some files. That's actually a good remark. And in case of my file, it won't. It will be 1 at least always, but that's a good remark. But if the file is smaller than 100 bytes, basically it would just go to 0. So if it's equal to 0, then count is equal 1. I'm just going to default to 1 in all cases. Yeah, I'm going to default to 8 now. I should do this. And the same actually here. So that's a good remark. Thank you. Shouldn't the index byte there's a question about this, shouldn't this be 2? No, it should be 8 actually, because in each, what we are trying to do is we're trying to, you know, in memory, right, every cell is, at least on x86, every cell is 8 bits. So that means that what we are doing here, having the number of the index of bit, we have to find which cell is it, and each cell again is 8 bytes, therefore we divide it. But then inside the cell there are 8 bits, so you just take the rest of the division, or the modulo, to know which bit of these 8 bits you are actually targeting. So that's correct. A lot of IoT devices have web interfaces, then a fuzzer would make sense too, I guess. It depends, like what you're expecting from the web interface. If you're attacking the website, which layer are you attacking, right? If you're attacking a website, if you're attacking the HTTP parser of the web server, because that's a different thing and you use different tools to attack it, or do you want to attack the TCP parser or IP parser or Ethernet frame parser or whatnot, right? For each layer, basically, you use the different technique, and for everything, like starting from HTTP parser down, using a fuzzer is a good idea. For web application, again, like just doing pattern exhaustive tests would be better. Okay, so the same person says that he used the fuzzer once on a website and found a heap buffer overflow. I guess if the website is implemented in C or C++, that also makes sense, and but rarely that happens, especially it happened, in the good old CGI era. I could try using visual block mode in Vim for editing multiple lines, especially if I encounter this kind of scenario. I do need to check how I can do it, because I actually have behave mswin in my Vim, and it kinda messes up the visual mode. I'm not completely sure if I can do it on my Vim, if it's like possible to do it. It's a good question, but I need to check it. Yeah, so Control V, and when you do behave mswin in Vim, Control V is just like paste. So yeah. What I can do still visual select this way, and then you see Shift I, yeah, and it totally jumps out of the visual mode. So yeah, no luck. Cool. So do I have mutators implemented? Yes, I do. I think I have them implemented. So let's continue with save file is already implemented, and then run is not implemented. Therefore, I need to just do this. And for the time being, I'm going to do subprocess. Will I stream tomorrow? Yes, usually Thursday I do the stream in Polish, and there will be a stream in Polish. At least that's the plan today, unless something comes up. Hopefully nothing will. What do I have to do here? Just, I guess, subprocess. Call is fine. Check call, check output. Check call is fine as well, and we'll throw an exception. That's good. And now exec name, and then input sample, just sample. Yeah. Okay, that's fine. Check call will actually, if the return value is not 0, it will throw an exception. Which surprisingly, on both Windows and Linux, if an application crashes, which with a like access violation or zigzag, then the the error code returned is not, the exit code is not 0. So this is perfect. I can do this try run except no, I'm going to like make it crash first just to see what exception it throws. I guess I could oh, this is here, so no, I changed my mind. Writing is hard. Okay. Yeah. It's probably crash. It's might be something else, but probably crash. Test.sample, I made a typo. Dick, thank you very much. Okay, let's see if it works. Let's see also how many typos I missed and how many typos you told me about on chat, but I didn't read it and therefore I missed. None. None is fine. None is okay. That's the default like return value in Python for functions which don't return anything. So that's okay. I shouldn't actually do it, I guess. And it didn't crash, but what I'm interested in is basically, did it create a test sample file? So yes, it did. It's 108 bytes. So let's compare it. I'm going to use total commanders comparing to do the comparison. How do you say it in English? I cannot into English, it seems. Okay, here we are. And it seems it did choose the byte. No, it chose the bit mutator, because as you can see, only bits are mutated here, right? Like you have 41 should be everywhere here, but only one bit differs in all of these places. So this is fine. It did work. It didn't obviously find a crash because, as I said, fuzzing isn't about one run. It's about 1 billion runs per second or whatnot. Well, it's about a lot of runs. Usually when you talk about fuzzing, you talk about how many CPU years you used to do the fuzzing in, at least on scale. So I'm going to remove the break, and I'm going to do this. Yeah, one. If I is equal to no. If I and okay is equal to 0. Then type print. Then type a dot. Sorry, like print a dot. So this is Python 2. If I want to print a dot without a space and without an enter, I actually need to import sys. And I do need to do sys write. So sorry, std out write a dot, and then I need to flash it, because sometimes the flash automatically happens only if you write either 1024 bytes into a buffer. Was like the default behavior on Linux, if I remember correctly, or when a new line is encountered, but only if you're operating under a console, blah blah blah. The logic behind when a flash happens is easy, but it's there basically. Struct is not defined. What really? Okay, so something is working. I see my CPU. Oh, this is even better. So the application crashed, and I do have a just-in-time debugger attached. And having a just-in-time debugger attached means that I can, I can already basically like start debugging it and wonder what happened, and analyze the crash. But it's not really useful for fuzzing because it's waiting for me to close the debugger to continue, but it did detect that it's a crash, so that's correct. I think basically the same thing happened on my Polish stream. So it does seem to work. I'm going to interrupt it, and I'm going to do a couple of things. First of all, I'm going to change this to a smaller value. Actually, I'm going to just do like true for now to see how many. That's not a lot of iterations per second. That's like 4 or 5 iterations per second. That's what basically to be expected doing this way I'm doing it. And it does find crashes, as you can see. So it actually, after finding a crash, what it should do, and what it's not doing that now, right? It should actually copy the test sample somewhere. So let me do a test, a save file again, and crash.sample dot, and here a number, and the number should be unique, but I'm going to ignore that for a second. I'm just going to do this, the counter, and then mutated sample. Okay, so it found a bug. Now I can actually, I'm going to, oops. Yeah, okay. I'm going to analyze the sample which is it found, and by analyze I mean I'm going to compare this crash samples file with my my input. Yes, again using the same method. So let's see what happened here. Basically, this is a byte mutator, right? And it selected this byte and this byte, and it actually arrived at a value which, like the value is 8. Like here, then 1 2 1 A. And this was multiplied then in the program by this value, which is 1 0 0 0 A. And And this is an overflow basically, because the result of this multiplication totally does not fit into a 32-bit integer, therefore the malloc allocated a too small buffer due to the overflow, and there was an attempt using the the for loop to read too much data into it, and that's what caused the crash, which again is exploitable and proves that our fuzzer works. Now, there isn't too much time left on the stream, so I'm probably not going to... Yeah, I'm not going to show you how to attach a debugger, but, well, it's in VLC it's rather easy. You basically create a GDB script that tells GDB, like, instruments GDB to attach or actually open a process, then run it, and then... Actually, maybe I can do it because it's rather easy. Yeah, let's do it, whatever. So, first I need to... Instead of running the exoname, I need to do this. I need to run GDB. Let me check if my GDB actually works with this target, because I honestly don't know which version of GDB do I have. Yeah, it seems to work, which is fine. So yeah. And exoname. Now, this is fine. Now what I need to do in GDB is I need to create a GDB script. I need to call it like detect GDB. It might be called fuzzer GDB, but doesn't matter. So set height 0 is probably the first thing to do, otherwise the GDB would just lock up in some cases. Then I need to do what I need to do. I need to run it, right? And I do know how to run it. Again, I'm going to hard code it. Usually you wouldn't hard code it. So run with a parameter test sample, and then it might crash or might not crash. If it crashes, then actually, well, we need to quit at the end anyway, because you know what, I need to actually pass this script to the GDB. So batch, and now, no, not batch. Batch is actually exit when you're done. X is execute, and now the name of the script, which is detect GDB. Okay. Now I probably should do, so let's do this and run, no, the one crash I have. Oh. It crashed, and now how do I know that there was a crash? I don't. Do I care? I don't. Good. So, I'm going to do IR, which is info registers, and then I'm going to basically, I don't know, let's say I'm going to print 10 instructions from the IP. I might want to set this assembly flavor until... Do you want to do anything? Oh, where is, like, where on the call stack am I? I guess I can do it in this order, so it's a little better. And then I quit. So, you know, if actually the application doesn't crash and just exists, then these three don't do anything, which is fine with me. And then, let's see how it behaves. So, X... detect GDB. Yeah, it died with a segmentation fault. Okay, and now I'm not going to use check call, I'm going to use check output. Oh, sorry, what's the... you know what I'm going to... No, does it... Yeah, it just... perfect. It just returns. So I'm going to check what's the error level here. I think the error level is going to be... Error level is the exit code, as you know. It's just 0, so that's okay, so it's not going to crash on me. I'm going to use check output, because check output actually returns whatever is written to here, so output, yeah, which is fine. And now what I'm going to do is I'm going to detect if there's any capital SIG or like program received a signal. If this in output, then return output, otherwise return none is fine, I guess. So this changes a little the logic here. Output is equal to run. If output is not none, then do this and save, and I guess also print the output. You know, you could just like remove parts of the output. I could Yeah, I'm going to do it. I'm going to modify the script a little. Obviously I did close, no I didn't, or did I? Yeah, obviously I closed my editor. So you do here, let's assume it crashed, therefore we do echo this. This is like a magic something. Maybe I should just like, yeah, looks more magic, doesn't it? Basically a unique string which is not anywhere else inside the script. And now what I'm going to do is actually, in this case, I'm going to do output. I'm going to split it. But before I go there, I need to check something. Does it echo the commands? No, it doesn't echo the command, which is perfect. Oh, the problem is here that it actually... yeah, that's not good. Because I do need to... Seriously, I did close my editor again. Usually when I close an editor, that means I will need it in a second. I'm going to move it here. Yeah. Okay, and now I'm going to split it with this, and I'm going to select the one, because everything, everything printed before it, right? Everything printed before this is going to be 0, then everything which I'm interested in is going to be 1, and then everything after is going to be 2. That's, you know, basic splitting. This is 2, yeah. And I actually am going to return this. Yeah. Since I'm actually running it under the debugger, then the just-in-time debugger will not pop up, so it will not block the fuzzing, which is perfect, which is exactly what I want. I also should actually like save the output, so I'm going to do this .txt and output actually. Yeah. Okay, so it looks good. Let's see if it works. Where are you? Here. 9.5, error on line 5. No, this is fine. Why did it hang my... Yeah, let's run it again. Did it... I'm wondering if it held my... Let's see if it actually held my mutator, like held. Yeah, it held my fuzzer. Why did it hold my fuzzer? I do have a queue here, right? I guess I'm going to add batch. Batch will force it to exit when the script is executed, so I don't need this queue here anymore. Yeah, now it works. I don't care about this error too much. I guess I should just remove... oh, maybe the application freezes, and that's why it holds... Yeah, that's fine. Yeah, I guess I should like take the standard error and actually put it somewhere else. So one thing which you can notice is that running under a debugger is actually slower, like it slows things down, right? But that's fine. I don't it doesn't matter. So let's let it run for a second, and I'm going to check if there's any question. No, there are no questions. So yeah, let's let it run. Let's see if it actually finds a... No, what? Actually annoys me. So instead of check output, I'm going to use popen, and because using popen allows me to do something else. Popen, that's p. And what I can do is I can do this is okay. Standard output is going to be I wonder if this will actually fix the problem. So I want to have like pipe for this, and for standard error I want to have none. Can I just use it none? Yeah, it can be none. Okay, perfect. Now I can do communicate. I think it's called communicate, yeah. Now I have double M, that's correct, and what I get here is I get standard output, so this is basically the output I'm looking for, and whatever, and then I do wait. So, no, I think I mixed up the order in which I need to call it. So communicate. Do I do first wait or do I do first communicate? Interacts, sends data, reads, waits for. No, I don't need to do it. Okay, so this is fine. I can close it. Do I need to close it? I don't know if I need to close it. I'm just going to not close it. Let's see if it works. Blah 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 blah. It's a capital P. This is annoying. Another way to fix it is actually to make GDB log into a file, but yeah, okay. I could change in the GDB script to actually log into a file starting from some point, and actually also detect if a signal was risen, which is a little harder to do. Let it run and let's see if it crashes. I'm going to also see if, oh, it did crash. Perfect, perfect, perfect. This is exactly what I wanted to show. So now my fuzzer actually works. It actually outputs a debugger report. It shows us where actually the crash happened, right? I see I should have used I, and I think I used X instead in my GDB script, whatever. Then there's the call stack, which tells us that it happened at line 22, and there are some like internals of C library which we don't care about because we know that the bug is in our program, and then the registers which we don't really care about at this point, but that doesn't matter. Now what I wanted to do here is obviously I wanted to do I, which is instruction. Okay, now there's a question, and I'm going to chat a little about, oh, I'm going to upload this code to my GitHub, so it's going to be here. GitHub/Gunveil, and then if you go, there's like stream en, which is the English version. So I'm going to put all the code here, which I've written today. It isn't too great. So now I'm going to answer the questions, and I'm going to talk a little about how AFL differs from this, as in how genetic fuzzing, which is currently used, differs from what I'm shown, which is called dump fuzzing. And the question is, I usually read security news, and somebody would really like to know my opinion on NSA and shadow breakers news. Again, I need to look into it a little more. I just read the press articles on it, but if I would state an opinion or just give you like some update on what is it about, I would have to look into it. Well, the bottom line is, like, if you did, like, were hiding under a rock for the last week, is that basically some exploits were released by shadow breakers, and the exploits are told to be from NSA or CIA or one of the three-letter agencies, and basically all the bugs are already fixed by Microsoft. They were fixed some time ago, like a month, 2 months, or 3 months ago. So yeah, but it looks really interesting, and there are some backdoors as well. I know some people on IRC asked me if I could analyze some backdoors on stream from there. So yeah, that's an idea. If you have any ideas, for streams, just put them in the comments under this video once it's already on YouTube. Also, my microphone is working today all the time, and obviously last week it didn't, so that's weird. And another question, are you from Melvin, are you also using Python subprocess to exploit STDN vulnerabilities? Yeah, sometimes. Depends on the exploit, but if I do need to interact with the application, then yes. Otherwise, I just generate a file and feed the file using bash, using the triangle brackets in bash, right? Cool. So how does the dump fuzzer, which I showed you today, differ from smart fuzzing? And if you would like me to actually, well, smart fuzzing isn't the correct word, from genetic fuzzing. And if you would like me to actually code a genetic fuzzer on stream, propose the topic, that's actually a good topic for the next stream. So if I want to find a better topic for the next week, I will just code a genetic fuzzer based on the fuzzer I have created today, just to show you the differences. But in short, basically a genetic fuzzer tries to monitor, when you have an input, it tries to monitor which branches of the application are hit by the sample. So let me maybe jump here and open our application in IDA. So this application isn't really a good example, but whatever. yeah, so basically if you have, you know, an application, you might have an input which goes, I'm just going to use these blocks as an example, so don't read the code, they're just like treated as an example. You might get an application which input goes like here to this block, and then it takes this red route, right? But you might also have another input after you mutate something that actually goes here using this green route and enters this block, and this block, basically by going this route, it unlocks another block. And now it might go, for example, here later on. Therefore, one input actually unlocked already 2 blocks now, which were previously unknown. So what the genetic fuzzing does is it grabs a sample, mutates it, obviously, then runs the application and checks which blocks are visited by the CPU during execution of this application, and it notes down the block numbers, the addresses or whatnot, right? And then it basically checks, did this sample cause the CPU to visit any block which was previously not visited at all? Therefore, did the sample uncover actually new blocks in the application, or did the input sample cover new blocks, or whatever you want to, however you want to interpret it? But in the end, that sample, if yes, if the answer is yes, it did uncover a new block, it's put into the corpus, back into the corpus, right? It's not being discarded. As you see, I just discarded mutated samples in my fuzzer, but in genetic fuzzing, you basically put it back into the corpus. And well, this idea is, I think AFL was basically the first fuzzer I've seen it, and I'm not sure if Michał Zalewski actually discovered it, but I'm pretty sure that's the first place I saw it. So, yeah, anyway, and therefore, what it turns out that when this happens, your genetic fuzzer is suddenly, from having a corpus which is going to only like go here and always here because that's your corpus, and doing random mutations, sometimes you might encounter this block, but you will probably never reach this block. You might suddenly start feeding the corpus with mutations which actually always reach this block, and therefore another mutation which will reach this block, and the next yet mutation will reach this block, and this block, and this block, and so on and so on. And therefore the coverage of applications, basically the state space of application is being explored in genetic fuzzing using, well, this automagic fashion, and it's really effective. It turns out it's really effective in finding new bugs, basically, which are not findable by a dumb fuzzer. Basically, it's improbable. Like, the probability of finding these bugs by a dumb fuzzer are minimal, but in genetic fuzzing you can basically find quite a lot of bugs just by just like having a input corpus with an A letter and then letting the fuzzer run. And in genetic fuzzing, I mentioned that another mutator group is used, which I called again appendif or additive mutators, which just is a mutator that appends data, like random data or like magic values or whatnot. Because you know, if a file is getting too small due to truncation, and then you start adding data, you need to be able to add data basically to the end of a file for this to be efficient. So yeah, that's how genetic fuzzing works, and AFL and HonkFuzz actually use this method, and it's not the only magic trick which they use. They are also, like, for example, the fork server, or using the dictionaries for fuzzing, or like, for example, AFL has a QEMU mode, but I guess we can chat about it next week unless a better topic comes up. So also let me know what do you think about continuing the fuzzing topics on my stream next week, and I guess that's it. So are there any questions? I think there's 1 or 2 more questions, and I'm going to finish for today. So yeah, let's get to that. Okay. So question from Dave is, when you fuzz an app, do you tend to use pre-existing frameworks or roll your own? So again, as I mentioned at the beginning of the stream, I actually do have a at-scale fuzzer which I usually use. So yeah, I guess that's the answer to that question, meaning I use a pre-existing framework which I actually developed with Mateusz Jurczyk with help of some other people. What about kernel fuzzing? Kernel fuzzing that's a great question actually. Kernel fuzzing is a little different. First of all, detection of kernel bugs is different because, for example, you know when you find the kernel bug, the operating system crashes. You get a blue screen of death on Windows. You get a kernel panic on Linux. So you need to detect these conditions. On Windows it's rather easy because you can just make Windows do a memory dump after a blue screen is encountered, and unless you are super lucky/unlucky for a bug to like screw the system up so bad that it's not even able to display you the blue screen, because you know the code displaying the blue screen of death also is still code, right? So unless you do that, then the memory dump of the system might be written down on the disk, and then on reboot you might have an event which actually grabs this and sends it to some other server. And when you do operating system fuzzing, you usually do fuzz syscalls. So you grab a random syscall and populate it with random or somewhat smartly chosen parameters, and then see what happens, as in if it crashes. Or you do like whole chains of calls to syscalls where, you know, one syscall creates an object and then another syscall grabs the object and does something on it and so on. Or you find the drivers and you communicate with them using reads, writes, or IOCTLs, sorry. Or you, I don't know, find some parsing functionality, like for example, Mateusz Jurczyk found quite a lot of bugs in font parsing, and up until Windows 10, font parsing was in kernel mode on Windows, which isn't the place you want to keep font parsing, and fonts are extremely complicated. If you're interested, basically look up Mateusz Jurczyk's or Juru's research. I think on Project Zero he published something recently, or am I mistaking? Let me see. I guess you would like to see the screen. Project, yeah, that's exactly what we wanted. Ian posted something, I didn't read this. This is like a super new, it's like from yesterday. Whoa, that's cool. I need to read through it later. Let's skip through Ian's post for now. Older posts. When this was published by Gal. Yeah, notes on Uniscribe fuzzing on from 10th of April on Project Zero's blog. You can read a little about fuzzing fonts on Windows, which is really interesting. So yeah, kernel fuzzing is also like a little is really close to fuzzing. Like user mode stuff, but it's a little different domain. Okay, that is a good question, by the way. API fuzzing, what about API fuzzing? Which fuzzer would I suggest? So it depends what kind of API do you have in mind, right? Is it, because, you know, API is basically a bag of terms of different technologies which you might have in mind. It might be like a web API, RPC API, or just Win API. So depending on what do you mean exactly, you basically use a similar approach to how you fuzz the operating system, or how you fuzz, for example, language interpreters, right? Or JavaScript, for example. JavaScript is a good example of API fuzzing, because you grab, well, basically a list of APIs, then somehow create a program out of it. There are ways to do it. Something, for example, like a Markov's chain that generates a valid JavaScript which gets executed, and obviously the parameters are being chosen either smartly or more randomly, and then you might actually, you know, find some bugs in not in the parser but in the API itself, because the idea here is not to fuzz the parser but to actually fuzz the API implementation. So yeah, that's one of the ways to do it. Cross fuzz was, for example, a good example of an API fuzzer crossfuzz you can find on Erkamtov's blog. It was created by the same person who created AFL fuzz. Yeah, so there's a follow-up on the kernel. I meant both Windows and Linux kernels. I mean, it's the same thing. As in, well, there are syscalls on both, right? And quite a lot of more syscalls on Windows, actually. Okay, I guess that's it for today. So thank you very much for staying late, and see you next week. Again, if you have any ideas for the streams, just, you know, put them in the comments down below. If you liked my stream, tell your friends about it. I mean, the more the merrier, and, you know, the more motivations for me to basically keep streaming. And thank you to Disconnected for being here and for passing me the questions. So I guess I'll be for some time on both chats if you want to grab me later on. And that's about it for today. So again, thank you, and I'm leaving you with some music by, again, as usual, Nervous Test Pilot. Bye bye. See you.